Hi, this video is about the four problem structures of multiplication and division. The first problem structure is called equal group, and it's when we have a number of groups and each of those groups has the same number of objects in it. So the size of the groups is the same for each, 2. The number of groups we have is 3, and so altogether the whole total is 6. And we can have problems where each of these parts is unknown. For example, if the whole is unknown, we can have a problem that says something like 3 people each have 2 cookies. How many cookies are there altogether? And that would be the whole of 6. Or we could have the number of groups unknown. A bunch of people have 2 cookies each. If there are 6 cookies altogether, how many people are there? And that would be the number of groups unknown. Or we could also have the size of groups unknown. 3 people have the same number of cookies each. If there are 6 cookies altogether, how many cookies do they each have? And you'll notice that the first one is a multiplication problem. The other two we use division to answer those problems. So whenever we have a number of groups where each thing has equal number, we're talking about the equal group structure. Now slightly different is the comparison structure where we have one set that we know the size of, and we're talking about another set being a certain number of times as big. For example, here we have a set size of 3 cookies, and if we want to think about another set that's 4 times as big as that, it would be a set of 12 cookies. For example, we could not know this product 12, and we could have the problem, Dr. Lucas has 3 cookies. If Dr. Ross has 4 times as many cookies as Dr. Lucas, how many cookies does Dr. Ross have? He has 12 cookies. We could also not know the multiplier, and then we would need division to solve that problem. Dr. Lucas has 3 cookies. If Dr. Ross has 12 cookies, how many times as big is his pile of cookies compared to Dr. Lucas's? Or we might not know the original set size either. Dr. Lucas has some cookies. Dr. Ross has 4 times as many cookies as her, and he has 12 cookies. How many cookies does Dr. Lucas have? And that's the original set that we don't know. So comparison, slightly different. We're just talking about 2 sets, one being a number of times bigger. The third structure is called combinations. Combinations involve counting the number of possible pairings between 2 sets of objects. Classic one here, you have 3 shirts and 4 different pairs of pants. How many different outfits could you make with those clothes? And so you could pair up your bowling shirt here with each of your pairs of pants, and some of you are saying, I would never wear that bowling shirt with those pants, or even that bowling shirt at all, but for the sake of the problem, we could have 4 different outfits from that, and another 4 different outfits from our t-shirt here, and another 4 different outfits from our green shirt, and so in the end we've got 3 groups of 4 outfits for 12 outfits. And so combinations rarely ask any other question besides what's the total number in all. Our last structure is the area structure, and this one's distinct because the product is a different type of unit than each of the numbers we're multiplying. For example, if we're thinking about a little carpet here that's 2 feet wide by 3 feet long, the length and width are each feet, but the area itself is feet squared. And so this is a very important another type of multiplication structure that kids need to understand, that we can find out the area of this carpet 6 feet squared, and you can count the 6 squares right here by multiplying 2 times 3. We can also talk about not knowing one of the lengths or the widths. We could say we have a carpet with an area of 6 and we know it's 2 feet wide, how long is it? Or it's 3 feet long, how wide is it? And those would also be interesting questions to ask with area. So those are our 4 problem structures, each slightly different than each other, but they're all related to multiplying and dividing in order to get our answers.